In this video, I want to have a look at translations of parabolas. So in our last video, we had a look at the equations of parabolas that had vertex at the origin and had a focal length of a. And those four equations were these ones here, depending on what the concavity was. But now we're going to have a look at parabolas that don't have a vertex at the origin. So we're still going to call the focal length of these parabolas a. And we're still looking at parabolas that have a directrix that's parallel to either the x or the y axis. But now we're going to have a look at if the vertex, it has coordinates h, k. Then these four equations are going to stay fairly similar, but we're going to add in this minus h and minus k. So for example, this first one was concave up. We had x squared equals 4ay. Now we have x minus h squared equals 4a outside of y minus k. So they all change the same way. The x has been replaced by that x minus h, and the y has been replaced with that y minus k. So our first question asks us to sketch the parabola with the equation x minus 5 all squared equals minus 20 outside of y plus 2. And we want to clearly indicate the coordinates of the vertex, the focus, and the equation of the directrix. So the first thing we should be able to tell is that this, look, comparing to our four standard equations, so we know it's going to be concave down, so we'll just write that. Then we can read off our vertex. So our vertex is going to be 5, because there's a 5 there. And this one here, that's a plus, but in our formula it was a negative, so that means the y coordinate of our vertex would be minus 2. Then we can use this term here to find our focal length. So we know that that term is 4a equals 20. That negative just tells us that it's concave down. And then that means that a is equal to 5. So now we can start sketching. So if we draw our axes in, put our x, put our y, we know that our vertex is at 5 minus 2, so that'll be over here somewhere. Let's go 5 minus 2. We know that it's concave down, so we'll draw it in. But we also need to show the focus and the equation of the directrix. So if the focal length is 5, that means that our focus is going to be 5 units straight down from there. So the focus is still going to have an x coordinate of 5, but it's going to move down 5 units. So we were at minus 2, now it will be at minus 7. So that there, the focus, has 5 minus 7 as its coordinates. And the directrix will be 5 units above there. So our directrix is going to go along here somewhere. Now it was at minus 2, we're going to add 5, so we'll end up with y equals 3 as our directrix. Our next question asks us to do the same thing, but this time our equation is y squared plus 4y plus 8x minus 4 equals 0. So we're not given it in that form that we can easily tell what the concavity is and what the focal length and the vertex are. So we're going to have to manipulate it. So if I write down that equation, first off, we'll have y squared plus 4y plus 8x minus 4 equals 0. So because it's got a y squared term, we know it's either going to be right or left. But we're going to have to rearrange it a bit. So what I'm going to do, I'm going to pull this 8x and the minus 4 over to the right hand side of the equation, and then I'm going to complete the square on those y terms. So I'm going to have y squared plus 4y, I'm going to leave a gap, it equals minus 8x plus 4. So completing the square here, we're going to halve that coefficient of y, which will give us 2, and then we'd add 2 squared, which is 4. Again, we'd have to keep it balanced, so we'd have to add the 4 on the other side as well. So now, rearranging that, we'd end up with y plus 2 squared equals minus 8x plus 8, which would give us y plus 2 squared equals, and then if I pull the 8 out as a common factor, the minus 8 out as a common factor, we'd have x minus 1. So what we can see then is that it's going to be, because that's a negative there, we've got our y squared, it's going to be concave left. And our vertex, so that's going that way, our vertex is going to be at the coordinates 1 and minus 2. And our focal length we can find because we know that 4a term is our 8, which tells us that a is 2. So now we can sketch it. So there's our x and our y axes. So we have a vertex at 1 minus 2, so around about here. So that's 1 minus 2. It's concave left, so it's going to go this way. And now we need the coordinates of the focus and the vertex. So, directrix. So our focal length is 2, which means our directrix is going to be 2 units this way. So it's going to be over here. And it's going to have an equation of x equals, well, if the vertex was at 1 and we're going 2 units this way, we're going to have x equals 3. Now our focus is going to be up here somewhere. My minus 2 is sort of in the way. I'm going to move that over here. So our focus is going to be about here. It's still going to have that y coordinate of minus 2, but we're moving 2 units this direction. So if that was a 1, moving 2 units would be minus 1. So our focus will have coordinates minus 1, minus 2. Our third example asks us to find the equation of the parabola with focus 3, 1 and directrix x equals 2. So to do this, we're going to draw a quick sketch to start us off. It only has to be really basic so we get the idea. So our focus is 3, 1, so that's about here. And our directrix is x equals 2, so that's 3, 1. X equals 2 is about here. So we can see from that our parabola has to be something like this. So it has to be concave right. So that means it's going to have an equation of the form y minus k squared equals 4a, x minus h. So we now need to figure out what our h, our k, and our a are. So our focus is here, and our directrix is here. Our vertex is going to be halfway between. So if this has a coordinate of 3 and this is 2, then that means that our vertex will have an x coordinate of 2.5. And it will still have that same y coordinate of 1. So that's our vertex. And the next one is our focal length, so our a. So again, if that's a 3 and our directrix is at 2, then the focal length will be half of that distance because we only want the distance from the focus to the vertex. So that's going to be a half. So we can substitute that in now. So we'll have y minus 1 squared equals 4 times a half outside of x minus 2.5. So simplifying that down, we can have y minus 1 squared equals 2 outside of x minus 2.5. Now we could leave it there. I'm actually going to expand it out and make it look a little bit nicer. So we're going to have y minus 2y, y squared minus 2y plus 1 is equal to 2x minus 5. And then bring it all over one side of that equals sign. So y squared minus 2y minus 2x plus 6 equals 0. So that there is the equation of this parabola. So those are a few examples of solving problems that involve parabolas that have been translated.